Good morning, Tiffany. We'll get started in about 10 minutes. Thanks for your patience. All right, everybody. Thanks for joining in this morning. Now we're going to go ahead and get started. As a reminder, this is being recorded. The recording started a little bit before our actual class time, so I have been kind of logged into the room for about 10 minutes so far. So I'll post it with the announcement when I post the recording that you might want to skip the first 10 minutes and then get directly to the actual content of our meeting. So just be aware of that. If you get some dead space at the beginning, it doesn't mean that the video isn't useful. Okay. So again, I will share this recording in the announcements once our class is over, and I can send the video out to get it captioned. Would somebody kindly unmute and let me know if you're seeing the course homepage?
Yes, ma'am.
Thank you very much. All right, so I always like to take a quick peek at the announcements. Just a reminder, I do post things there that you'll be wanting to take a look at, the course recordings and any other relevant information. So, don't overlook the announcements when you come into the class. I know the tendency is to jump right in and get started with the work, but take a moment, look at the announcements, and you can even go in your profile here on Canvas and set the notifications, right? It'll allow you to, choose what notifications you get. So, if that helps, feel free to go into just click on the little account icon and go in and update those. All right, so here we are this week dealing with kinematics. Okay. And this goes hand in hand with the stuff that you learned last week in lecture. For those of you who have me, last week we learned some basics regarding the properties that we measure for moving objects, things like position, velocity, speed, acceleration, time. And we looked at various equations and formulas that can be used to determine those descriptions, as well as how we could use motion graphs to help us, determine those descriptions. And if you recall, we're doing that from a kinematics perspective, meaning that we don't care about force, or we don't care about what causes the motion. We just want to analyze pure motion. Okay. And so that's what you'll be focusing on in this experiment. My hope with this was that you've had time to digest the material from lecture from last week, and now you can come into this particular overview and have it make some sense. In fact, those of you who have me for lecture, problem set number 3 and the experiment that you'll be doing here for this overview utilize the same simulator, although you're doing different things with it. Okay. So as a reminder, these are the items that you have on your plate for this Saturday. And I will cover each one of those, the experiments, lab report, post lab, in terms of what you need to get done. I made available to you some materials from our lecture textbook and some videos. Of course, you have access to resources under useful links. And those of you who have me for lecture class, you have access to some additional resources that can help you with this material. Okay. So any questions where we're going so far?
No, ma'am.
Okay, thank you. So let's take a look. Let's take a look at the experiment handout, and you'll find this experiment handout very, very familiar, because as I said, you'll be utilizing the same simulator that you used in lecture class, but you're going to be using it to do something different this time. Okay, so you can see our objectives center around utilizing motion graphs and equations and looking at the relationship between position, velocity, acceleration, and time for a moving object. Okay, so To get to the simulator, you click the link. All right. And so this is the same simulator that you use for problem set 3. So it works the same way. You come in, you can change the starting position values. So I'll just change it. So you see if you change the initial position, it changes where the car starts from. I'll start it at 0 since, you know, we want to use as much of the track as possible. You can decide what the starting velocity should be. So, okay. And then you can also change the acceleration, but remind you that the acceleration can not be larger than 2. Okay. So if you try to put a number in bigger than 2, it's going to keep kicking you back to 2. So values less than 2 are just fine. Okay. So you see, I've set some initial conditions. These buttons down here, it doesn't matter which ones you choose. They do the buttons do relate to vectors, so it could be a helpful visual, especially if you want to see what it looks like as the car is moving. Okay. But then you can start it, and I'll run it in slow motion. So you can see the car is in motion. There are 3 clocks. The green clock keeps track of the time that it'll take the car to reach the green flag. The red clock will measure the time that it takes for the car to get to the red flag. And then the gray clock keeps track of the overall time. And you can see that until the car reaches the red flag, the red clock and the gray clock pretty much read the same. But once the car gets to the red flag, the red clock is going to stop. And then after it passes completely the red flag, you want to pause it. And now you can see that the overall time is different from what the red clock measured, because if you let it keep running, this time will keep increasing. So after the car fully passes the red flag, stop the simulator, hit the pause button. Okay. So the nice thing about this simulator is that as the car is moving, you know, while the car is in motion, the graphs are being made for you based on the numbers that you put in as your starting values, as your initial values. Okay. Sorry, everybody. That's my email still open. Okay. So if the numbers in the boxes were different, then the graphs could potentially look different depending on what values you pick. All right. So this simulator is using your starting values to build the graphs. Now, what's happening behind the scenes to make these graphs using those numbers? Well, if you recall, in lecture class, we looked at 5 equations that are called the equations of motion for constant acceleration. And in particular, we're interested in those equations for horizontal motion with constant acceleration. So we're interested in X, the equations utilizing X. If we were looking at motion with constant acceleration where we were dealing with Y, we would be talking about free fall and gravity. But since this simulator does not deal with vertical motion at all, there is no gravity or acceleration due to gravity involved. Okay, so this is not free fall. This is horizontal motion with constant acceleration, and the equations of motion are being used behind the scenes to create these graphs using the starting values that you put in. Okay, so do all of you understand how this simulator works?
Yes, ma'am.
Okay, anybody not sure?
I do, like how to put it, but like for the lab report, you're just going to give us what we need to type in.
I
So
have
it-
not got to the lab report part yet. I just want to know, do you understand the simulator?
Yeah.
Okay, if you're good with the simulator, then we'll get to the lab report part, but we need to talk about what you're going to do with this simulator first, and then we'll talk about what goes in your lab report. Okay, so again, what are your questions regarding the operation of this simulator?
I
All
have
right.
no questions.
All right, cool. So we're good with that. Let's take a look at, oh, my bad. I had a document open. Let me open it up again here. So this is the actual experiment handout. Remember, the experiment handout is meant to be a guide to you, a set of instructions that you follow. So the procedure, go out to the simulator. We took a look at that already. So what you're going to do is you're going to change the simulator values 5 times. You're going to put 5 different sets of numbers in. And remember, for acceleration, you can't go bigger than 2. So, you know, I've had students say, well, you got 4 in the window there, but I'm just giving you an idea that you need to change the values 5 times. But the biggest value for acceleration is 2. All right. So every time you put numbers in the simulator, you need to run it and create the graphs. All right. So you'll have 5 different simulator screens. So you'll get 5 of these because you're changing these numbers in the box 5 different times. Does that make sense to everybody? Okay,
Yes, ma'am.
thank
We
you
just
very much.
make up our own numbers. 5
Yes, you
different
make up
times.
your own numbers.
Okay.
Yep. Just remember the acceleration can't be bigger than 2. All right. That makes sense to everybody?
Yes, ma'am.
All right. So let's talk about the data, right? Because you're doing an experiment. Let's talk about the data that you're going to get. So the screen captures or the printouts from the simulator are your data. So in other words, these 5 screens, you need to provide those to me. Now, some people have computers where you can do a screen capture and you can just do a screen capture, for example. So I'm going to do a screen capture now. All right. And then once I do a screen capture, I could just open it in a Word document and paste it. And I could do that 5 different times and I could send that document as proof of your, proof that you actually ran the simulator 5 different times. Now notice that this screen here is kind of small, but if you just write out the numbers on the side here, if your screens are small like this, it doesn't have to be in color. It can be in black and white. As long as I can see that you ran the simulator and that I can see that the sets of numbers that you put in each time are different. Okay. If you are not familiar with doing a screen capture, or if your machine doesn't allow you to do a screen capture, what I tell students is you have to be careful, because if you have an older model computer, if you go up here and just do file print, it's going to print a gray box. Okay, but if you have one of the newer model computers, you can print and it'll print it out just fine. And what I tell students is if that's how you have to, if that's how you do it, you can either take pictures of the printouts, or you can take, you can scan it. I've even had people take their phone and take a picture of the screen with it on there. And that's fine too. Just some way of communicating to me that you actually did run the simulator 5 different times. Okay. So do you understand what you need to turn in as far as data goes?
Yes, ma'am.
Anybody not sure about the data part of this?
Just double checking. A picture with the phone on the screen will be perfectly fine, and that's
That's
okay.
absolutely correct. As long, I always tell
As long
students,
as it's visible and you can see everything.
that's correct. Because if you
Clearly.
take pictures like me, I always tell folks I'm the worst photographer in the world, because if I take a picture of a person, you can rest assured their head's going to be chopped off, right? But if it has to be
You're looking
readable.
at the numbers, basically, like that's the main
Yeah.
part for it.
Yes, that's correct. It has to be where I can tell what your numbers are.
Okay, all right, just double checking. Thank you.
Yeah, no worries. Anybody else, please ask, because sometimes this is a sticking point for students. They get here to the data and they're not sure what I want them to do. So I want to make sure you understand that. All right, so now here we get to the analysis part, okay? And kind of pay attention to this because this sometimes gives students a little bit trouble because either they've not been in a lecture class where I talk about these equations, or they don't know what equations I mean, okay? So what I'm trying to get you to refer to in this analysis portion are those 5 equations of motion for constant acceleration. And that's why I give the hint here. I say it's kinematics, okay? So here's what I want you to do for the analysis. I need you to go out and find those 5 equations of motion. Those of you who have me for lecture, they're in the lecture notes, okay? If you don't have me for lecture, you can Google kinematics and the equations of motion for constant acceleration that have X in them, not Y, because we're not doing vertical motion. Those will be the equations that you need to refer to. And what you're looking for is an equation that deals with position and time. Remember, position is X and time is T. So we're looking for an equation that relates to this first graph here. Okay, see, because this is X and T, right? And then in the second paragraph under the analysis, I'm asking for an equation that deals with velocity and time, V and T. So in other words, what equation goes with this graph? And then finally, I ask you about the acceleration in time. So I'm asking you what equation can make this graph? So you're looking for a set of equations that deal with horizontal motion, because the car is moving horizontally, with constant acceleration. And in particular, you want the kinematic equations, because those equations don't deal with force. We're not equipped to deal with that right now, okay? So you're looking for those equations. Those of you, again, if you have me for lecture, I specifically shared with you those equations, and I even mentioned that those equations would be important to you in the lab class, okay? Now, here's what you need to do. Once you find those equations, I want you for at least one of them. When I mean that, at least one of your sets of graphs. You don't have to do it for all 5, but at least one. I want you to take your starting values for position, velocity, and acceleration, and I want you to put them into these 3 equations. In other words, fill in your value for A, the starting velocity, and the starting position. The rest of it, leave it blank. Don't put any time values in because you don't need to solve, okay? All right, so what you're gonna have then are the 3 equations that can be used to make your graphs for the numbers that you picked. Okay. What I'm trying to drive home to you is that those equations of motion for constant acceleration are relevant to how these graphs look, because they will look differently depending on the values that you choose. Okay. So all I want you to do is I want you to show me each equation, and then at least once I want you to show me those equations with your starting values. Does that make sense?
Yes, ma'am.
Yes, ma'am.
Okay. Now here's what, I'll come back and say to you, as I always do. If you're working on this experiment and you're not sure about anything that you need to be doing, I need you to be reaching out to me, okay? Because this experiment is pretty important, because it establishes for us the ways that we can describe a moving object. And that's a big task for this course. If I had to choose, I say, 75 to 80% of this course is nothing but you learning how to describe the motion of objects. And so these equations are really one of the biggest tools that we have. And so I want you to see the connection between the blank equations with nothing in them versus the equations with your starting values in it, okay? Because what could happen is if we took the equation with your starting values and we drew a graph by hand, they would look just like these. So I want you to see the connection there, okay?
I'm sorry, I had lagged out on my laptop. You said we have to plug in our values we chose into the equations.
Yes, yours to put yours at least once. Take those
Okay.
equations of motion and put in your starting values. Do not put in time because you're not solving, just the starting values that you pick.
Okay.
All right. So that takes care of the actual experiment. Now, let's talk about what you have to do for the lab report. See, what goes in the lab report, kinematics, right? So here, now, this is the first time in a minute, since your very first experiment, that you'll have to actually write a lab report, okay? This is the first time since then. And I do plan on getting to my grading tomorrow, and you know, even if I have to get up in the wee hours of the morning Saturday, so that I can provide you some feedback on your first experiment, so that when you go to write this second lab report, you'll have chance. I do apologize. I have been like inundated with so much stuff at work lately that grading was, you know, it's just like I had to prioritize. And not that you guys aren't my priority, you are, but you know, when the boss is breathing down your neck for things to get done, well, you know, something has to give, right? But Friday and Saturday, I'm just not going to answer them for any reason. They'll just have to be mad, and I'm going to get at least your first lab report graded, so you know when you do, you know, when you're creating a lab report, these are the kinds of things that you want to be doing, and you'll have that as a guide to help you with writing this lab report. Now, granted, this lab report is very different because you don't have a big bunch of data tables, and you don't even have calculations that you have to do, right? Because all you're doing is printing out the pages, writing down the equations, and putting in your starting numbers. You're not solving for anything on this one. So that should make it a little bit easier in terms of what you have to write. The bulk of the attention for this lab report will be on the abstract and the conclusion, to be honest with you, right? Because this is the first time that you're going to have to write an abstract for a simulator, okay? And it's a little bit different, right? Because when you explain the procedure that you follow, well, basically, I outlined that procedure for you in the experiment handout. So if you just want to paraphrase the procedure that you follow from the experiment handout, that would be perfectly fine. When, you know, in this particular case, under how you did it, you don't have cans of items and things like that. And you don't have rulers and, you know, any measuring devices, but you do have a website, right? If you don't put the website for the simulator in your lab report, then how will somebody find it? So you have to give the URL or the website address of the actual simulator that you used in this case, right? That's your equipment. So that goes under how you did it. Okay, and you cannot tell me I used the simulator that Dr. Zenon or that the instructor provided. That doesn't help anybody who's using your lab report to repeat the experiment. They, you know, they don't need to know what I gave you. They need to know what to do and how and why from you with sufficient detail. So you have to include the website. Okay. Why you did it? What was your purpose for doing this experiment? Okay. Again, that's pretty well outlined in the experiment handout. What you found. Now, this is where you can interject, you know, your own thoughts into this whole process, especially because if you know, it asks you for something that you figured out while using the simulator. Okay, it says, discuss something that you figured out about how the values in your data change as you manipulate the simulator. So for example, as you change the velocity value, what happens to the simulator? As you change the acceleration or the velocity, what happens to the graphs or the simulator as you do that? I'm not asking you for specifics of what your numbers are. I'm just asking you to discuss with me maybe some overall patterns that you noticed as you manipulate the simulator, okay? So abstract, what are your questions for what regarding what I'm looking for?
I don't have any questions, Ms. Zenon.
Good, thank you. Again, if you're working on this abstract, I know this is only your second time doing it, and you're not sure about something or you have questions, don't hesitate to reach out to me. I always tell students, better to ask your question and do a good job with the abstract than to have questions lingering. And after you get your score back, say, oh, I thought that was it, but I wasn't real sure. You need to be sure. So ask me, okay? Your data and analysis in this case is the printouts, from your simulator screens and the equations, and with an example of at least once where you fill them in. That's what your data and analysis is. And then your conclusion, again, this is where you can interject, because you can tell me what you learned from all this, not what you did, not that you figured out how to use a simulator. Tell me something that you know about 1D kinematics that you didn't know when you started, okay? So don't tell me what you did using the simulator. Tell me a concept, a formula, or something that you learned about 1D motion that you didn't know when you started, okay? All right, so are all of you clear on the data and conclusion portion of the lab report?
Yes, ma'am.
Yes, ma'am.
Great. All right.
Yes, ma'am.
So you see you have the submission instructions here that tell you how to turn it in. By now you know that you're emailing me things, but it's also here. And then class questions. Remember, that's your space where you can interact with your classmates regarding this material or anything regarding the course, so that you have opportunity to have interaction with your classmates, beyond the discussion that you have to complete for me. I always tell students, the post-lab discussions you're having with your classmates for me, so that I can see what's going on. The class questions is where you can have class discussions with your classmates, where that's your own space to do those kinds of things. Yep. Okay, so now the post-lab discussion. So in this post-lab discussion, there are 5 questions. You have to answer these questions first, and then you have to come back and respond to 2 of your classmates posting. And the goal is that you want to try to put yourself in a frame of mind. Hey, we're working together in a face-to-face classroom. We're working together to answer these 5 questions, so let's have a dialogue just like we would if we were in person working in a group. Okay, that's what the flavor of this is supposed to be. Not just, hey, we got the same thing, or hey, I like your answers. Dig a little deeper and try to have a discussion. What would you ask them or talk about with them if you were in the actual classroom space and they gave these and they put the answers to these 5 questions out there? Okay. Any questions about the discussion?
No, ma'am.
Okay. So that's pretty much what I wanted to cover. I told you guys, the lab class, that's why sometimes we don't have to meet on Tuesday. Or there may be times when we'll meet on Tuesday and not Thursday. because it really doesn't take me a whole lot of time to go over this and just make sure that you have a strong foundation in what you need to do. Other than that, it's for you to go do it, right? Even if we're in a face-to-face class, you wouldn't do the simulator in class. You go home and do it, right? So unless there are any more questions, we're pretty much done. So I'll stop the share. Any questions for me?
No, ma'am.
All right, everybody. Well, thank you for joining in today. Hope everybody